Welcome back to the channel. This is Earth Science Classroom. This video is on volcanology and looking at the term viscosity and how this applies to fluids and liquids like magma. This is the Earth Science Classroom. Welcome back to the channel. Viscosity is a word that derives from Latin, which means sticky, because in that region of the world where Latin was used in the past, there were these mistletoe berries that if you squeeze them, they formed a sticky glue. So the term viscosity comes from the stickiness of that berry, which is kind of a cool fact. Now, viscosity is defined as the resistance to flow of a liquid. So this liquid does not want to move. It has resistance internally with the molecules and friction, and the higher the viscosity, the less the liquid wants to move, and the higher the resistance to that movement. And you can imply the higher the friction that occurs within this substance, within this liquid. Now, the word fluid means to flow, so the substance is going to flow. Solids do not flow. Liquids do, and so do gases. So a liquid is a fluid, but a fluid is not always a liquid. A fluid can be liquid or gas. And the term liquid refers to a definite volume with no fixed shape. And that shape can change based on what the liquid is placed in, the size and shape of the container or the volume it is occupying. Now, with viscosity, you can also discuss the shear motion, which is a type of force that's applied to the substance that will cause internal movement, which is shearing, whereby one part of the substance, or liquid in this case, will be moving and the other part will not. So there'll be a resistance and friction between the parts that are moving and the parts that are not within that one single substance, in this case a liquid. And we can also discuss Mr. Isaac Newton. Newtonian fluids are ones that have a consistent viscosity throughout the whole substance. For example, water. When you pour water, it has a constant flow and the viscosity is constant as it moves and flows as a fluid. Whereas a non-Newtonian fluid would be like peanut butter, where different parts of the peanut butter, the substance can move and other parts cannot. So there is differential viscosity or different amounts of viscosity within that one single substance. So peanut butter is a great example. Now, how do we link this and relate this viscosity to magma? Well, first, magma is a semi-solid liquid substance. It may have solid minerals inside the magma, its composition based on the temperature and the melting point of a specific mineral. But generally, this magmatic material or substance is a liquid and it does flow. The flow rate and the speed of movement can change based on the viscosity of the magma. The higher the viscosity, the higher the resistance, the slower it's going to move and the higher the friction. Whereas the lower viscosity, the lower resistance, the more movement or flow rate of that magma, and the less friction. So in conclusion, viscosity is the resistance to flow of a liquid, and magma is a semi-solid and liquid substance which does flow, so we can apply viscosity and the amount of movement and resistance to the magma and different types of magma. This is the Earth Science Classroom. Thank you for watching the video. I really appreciate it. And if you get a chance to like and subscribe, that stuff really helps the channel. Thank you so much. And see you again in a future video.